Okay, so let's start. So yesterday we discussed about the equals method, two string method, and the last part which is pending is the hash code method. So we understood yesterday that there are like if you have to work with collections, right? If you have to work with collections, right? And you since collections only work with objects, right? They don't work with primitive data types. What is required is that first of all the one of the thing is that collections only work with objects. Now the second part is that you could have multiple kind of objects. One is like a string, which is an inbuilt object, right? Which you can use. Similarly, the wrapper classes for all the different types of primitive types, right? Wrapper classes are what like integer, character, right? And the other remaining ones, right? These are here coming from here, and this string class, right? What has happened is because these are all coming from the Java side only. The developers are providing from the Java side. What they have done is so we yesterday learned that like there is a super class for all the classes, and these string and wrappers, right, are derived from that only, right? This one and this one, right? Both are derived from the object class. Object class has three methods, right? Which are of importance for us, which are toString, equals, and hash code. Hash code is the last part which we have not discussed yesterday. We'll discuss today. But the point here is that when we have to compare two objects, right? When you're comparing two objects, when you compare two objects, there are two ways to do it. One is by doing a double equal to, right? And one is by saying this by using this method equals here, right? When you use double equal to, right, it will always check the value placed in the call stack. Okay, it will always checks the value in the call stack, right? What does it mean? It means that the in the call stack, right, in the call stack only the memory address of the object is stored, right? So in that case, if this has to match with this, right, both have to be pointing to the same address in the heap, right? So both should be pointing to the same address in the heap. Let's say this is heap address one, right? So both of them should be pointing to this address only. Only then this will return as true. Only then this will return as true, right? Now this could be a problem. This could be a problem because in some of the cases, maybe you do not want to have like same like see you are creating only one object, right? You're creating only one object, right? And you assigned o1, let's say you created this object obj, and you assign it to o1 and you assign it to o2, right? Both of them are pointing to the same object, right? So they will always be same. So they will always be equal, right? Even with the equals method also and double equal to, right? What we want is that we have two objects here. We have two objects, let's say obj1 and obj2, right? The value which they have is same. Let's say it is also having a kill and this is also having a kill, right? What we want is if we are comparing this obj1 equals to obj2, right, we want this to be returning as equal, right? In the usual approach, right, in the usual approach what will happen is obj1 is pointing to this address which is ha1, and this is pointing to this one, right, ha2, right? Right. So what the whole discussion is about, like how can we make these obj1 and obj2, right, being equal. So in case of strings we have a concept of string pools, and it depends on that, right? Or if you create a string outside the string pool, then you have to do something else, right? So this still compares the call stack, right? Okay, the value placed at the call stack. Now what the developers of the string has done is they have overridden this equals method. Okay, they have overridden they have overridden the equals method here, right? And they what they're saying is instead of comparing the address of it, right, they the address of these objects, they compare what, they compare the value which that object has, right? Let's say Akhil and Akhil, right? This value, they are comparing these value when it comes to this, right? Now this is something which the Java developers has done, right, for these classes, string class or these wrapper classes, right? So equals method here, right, compares what, it compares it checks the exact value, right? Exact value that variable holds, right? Not the address. It checks the exact value, not the address, right? It does not check the address. Okay, it checks the value. Okay, and similarly for these classes also. Now we want a similar behavior for our custom classes. So we yesterday saw that we can create a custom class which could be a laptop, right? Which could be a laptop, and over there we can have this behavior where we say laptop name, right? Let's say laptop name. Now, if you create two objects, let's say L1 and L2 here, right? Pointing to new laptop, and let's say Apple, and let's say new laptop, Apple again, right? So if you do this, L1 equals to L2, right? This will always return false because these are two different objects pointing to different memory addresses, right? But what we want is that we want to override that behavior that whenever we do this, right, equals L2, right? It should return me true. Let's say we want this behavior, right? We want that if this is getting compared, this should return 2. In the default approach, this also checks the memory address only, right? But we want to override this. Okay, we want to override this. Instead of checking these locations, right, they should check these values. Okay, we want that behavior. Now we yesterday saw that even after implementing the equals method, right, it was not returning true. So now coming to the last part, which is that if you want your custom objects, right, to behave same, right? I mean, if you want it like that, if you do L1 equals to L2, it should return 2, right? You have to do two things. One, you have already done, you have overridden the equals method, right? You have already done that. But the second thing which is pending is you need to also have the hash code method being overridden. What is hash code? Let's go to into that direction now, right? Into the discussion now. So let's go it here. So if we check it now, this is Java demo, and this is what we were doing yesterday. Let me run it once again, just to show. So we have Apple and Apple 2, right? Both are having the same values. If I if I am running is equal, right, which is double equal to, it was returning false, right? And even if I was doing with the Apple method also, it was also returning false. And you can see the laptop method, right? I have laptop class, I have already overridden the equals method. It was still returning me false and false. Let me run this. You can, oh, why is it saying equal now? Okay, okay, it was able to say equal. Okay, just a second. Are we calling the right method? Hashing demo. Okay, is equal. We are calling apple with apple 2, right? So now it is able to say equal. Okay, 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 fine. It is saying equal. Let me check the hash code value for them. They are able to say equal. Okay, great. So let me print the hash code value of them. So let us see this. So we'll say s out s1, sorry, s1 dot hash code. Okay, let me print this. This is for s1. This is for s1, s1, and let's say we'll do it for s2 as well. This is for s2. Let us print it. So it already has a method over taking from the object class, right? Let me put it here. Let's check this out, and let's run it now. Let's see what is the behavior. Okay, let's run this. You can see the hash code value of these two objects are different, right? This and this is this, right? Now, why do we need to? I mean, okay, see, the point here is, so what is happening is that equal method is able to compare. Okay, so equal method is able to compare these two objects, and it is able to, because we overridden this method, I believe. Then that's the reason it is saying this. But we also need to work on the hash code level. Let's say I introduce one more variable here, right? Let's say I introduce one more variable in the laptop thing. So I will do something like this. Laptop name, and I will do this public uh, string. Okay, okay, one more thing, right? Just one more thing. Let me do one more thing. Let me first add. the let me first override the hash code. Okay, let me write the override the hash code. So I will say public int hash code, and this is a override method, override, right? And I will do one. Let's say I am going to return one here, right? Let's say I'm going to return one. Okay, and let me comment this out. I'm commenting the equals method now. I'm commenting the equals method now. So the default implementation of equal will work. Okay, the default implementation of equal will work. And I have set one here. Now let me go and run the same method again, right? Let me run it. Let us see what should happen. What do you think it should do? I have removed the equal logic, right, which I have created earlier. So this should still return me false, right? And this should do what? Sudhakar, any input?
It will be equal.
It should be.
I mean, we are commented override method, right? It will give true, I guess.
I have overridden this, right? Why it would be true?
Yeah,
So I mean, I have commented this equals method now, right? So the equals method is now commented. So if you it will be going and checking this, right, it will be calling this equals method only. And now we are not comparing these two objects, right?
yeah.
These would be having different address positions, right?
And now we are override with same value, right? HashCode.
No, right? I'm not. See, first of all, the equals method is gone, right? Equals method I have commented out, so I'm not overriding. So by the default nature of equals method, it compares the memory address, right? So it will be doing that. But what I'm asking is, so you think, okay, tell me just one answer. Do you think it would be true or false? So the first one returns false,
The
which
first
I'm
one,
first one is false because it uses double equal to, so it will be always false. What will be in this case?
second one also will give false, I guess.
False, right? Okay. Why? Because we think that we have overridden the equals method, right? The equals method, and with equals method, I mean, we have not overridden the equals method this time, right? That is the understanding. So let's run it and see what are we doing here. Okay. You see here, first of all, the hash code is 1 1 for them, right? Because I have overridden the hash code, right? If you see, the hash code has been overridden, right? Like this. Okay. Now, this is one thing, and the objects part, right? Okay. This is one thing, right? And now the second part, right? So this is not equal, which is okay, right? Which is okay. And if I remove this equals method now, right? And if we run this hashing code, let me run it now. It should be equal. This is equal, right? And let me do just one more change. Let me do one more change. Now think about this, right? I'm saying this now. I'm saying it has a laptop name, and let's say let me introduce one more thing to it. I will say public int ID. Okay, let's say ID, and I'll change this. I'm going to say int ID, and I'm going to append the logic. This dot ID equals to ID, and what do I have here? Two string, right? So it is written in the laptop name, which is fine. This is boolean equal hash code, and these are public, right? So if I go here, right now, let me give the ID, right? So here I'm saying it is has an ID one. Here I'm saying it is an ID two, right? And here I'm saying the ID would be three. Okay. Now this is what I did. Okay, and let me do one additional thing here. So if I go back to the hash code, right? Hash code. Uh, should be doing what? Should be, let's say. Let me just ask the friend. I think I can generate object dot hash. I can't do this. Just a second. Hash code. Uh, generate hash code for my for my class in Java. Object.hash, objects.hash. Okay, objects.hash, right? So objects.hash, objects.hash, hash. Okay, so we need to give this code, and this will return me what? This is going to return me int value, right? So what I will take from here is I will use the this thing, right? Laptop. So I'm providing laptop here, and let's say I'm providing the ID here, right? The ID part also. Now let it generate the hash code, and let's go and run this first. Let us see. Don't focus on equal not equal right now. Just focus on the hash code value which it will throw. If you would see, these are somewhat different, right? This is this 3640. This is 3642, right? This is like this, and still says equals, which is fine, right? Now let me first complete our discussion, right? So what we are saying, right? See, double equal to, we are clear, right? This happens when address is same, right? Address is same. So this is very same, and we are discussing about objects only, right? Discussing about objects. So in case of object, if you do this, it will always check the address, and if it is same, then it will say same. Otherwise, not. We are talking about equals method right now, right? And the whole point is that we want to compare two objects. We want to say obj1 dot equals obj2, right? Now we have, now there are two things in Java, right? One is the equals method, right? And second is the hash code. Now, what is happening is, when you do, what is the purpose of equals method, right? Here you want to okay, let me again create some laptop, right? So it is L1. L1 is pointing to Apple, right? This is like a new object here, right? New. This is new. L2 equals to, let's say, Lenovo, right? This is this, and this is again Apple here, right? New Apple. Now what happens is, right, you have three objects. You have three objects, L1, L2, sorry, uh, not L1, L2, L3. This object, this object, this object, right? This is pointed by L1, this is by, let's say, L2, and this is by L3. Okay, this one is Apple, this one is Apple, and this is Lenovo. Okay, now let's say my ask is that I would be inserting these, right, in the map like this. So I would be inserting in the map, and map looks like this. Map has a key and value pair, right? Key value pair. Now we know that if you, let's say I am using what we should say, L1, L2, L3, right? Let's say I want to use this L1, right, as a key, right? I am using the laptop as a key, right? Laptop as a key, and maybe value as the entire object, right? Whatever that is. So maybe the name of the name of the class, name of the laptop will be here. Now what we'll do is, we will be inserting L1 here, right? As soon as I do L1, right, it will check, is there an L1 already existing in the map or not? It will say no, there is no entry, right? So it will, let's say, it will add Apple here, right? As a value, I've done this, okay? And this is, mind you, this is a laptop thing, okay? Now I'm saying go and add L2, right? Again, it will check, do I have an L2 here? It will say no, right? So here it will go be able to add Lenovo. Now in the third thing, right, we know this is, we are putting L3 here, right? L3 here, which is having Apple as a value. If we put L3 here, right, if we try to see for L3, right, it will try to see, it's a new object, right? It's a new object. So that object does not exist here, right? But, and it will say Apple here. We do not want this behavior. What we wanted was that it should have added here, right? We wanted this to be having to, be able to treat this as same, because these are having same values. Okay, and this should have given me, it should have this only, right? It should not do this. Okay, let me say I'm not using this, I'm adding frequency counter, right? So it is one earlier, and now if I'm looking at L3, right, it should not add an entry L3, it should say L1 and plus one here, right? But that is not what will happen. To make it happen, right, what we have to do is, we have to make sure first of all that when the collection is checking, see, this is a hash map, right? This is a hash map which is a part of collections, and while making the decision whether the key already exists or not, right? Inside the map, it checks for two things, right? It checks for the hash code of that object and it checks for the equals method. Okay, it checks both of them. It checks both of them, not just one, right? Okay, not just one. If both values are same, I mean, if both, if let's say for obj1, right? For obj1, for L1 and L3, right? Let's say for L1 and L3 equals is working, right? Let's say, right? Like this. Okay, and hash code is not working, right? And hash codes are not same. What will happen is it will still treat them as three different things. If you want this L3 and L1 to be treated as one, right? What you should need to do is you need to make sure that both objects are returning the same hash code. Okay, that is the whole point. And this is only needed for what purpose? For the for these collections which uses hash. Okay, what are those? Hash map, hash set, right? These methods. So again, going back to our discussion here, right? If we see this, right, we just saw that if you just if you see this, right, what we have done is we have overridden the equals method, right? And let me just comment this again. There are two perspectives which we have to compare. Okay, there are two perspectives. One is the perspective that you are not using a hash map, right, to make a decision whether the entry is there or not, right? Let's say the first case is that you yourself wants to check whether two objects are same or not, which is by doing this obj1 dot equals obj2, right? If you want to do this, if you want to do this, right, if you want to do this, what you can do is you can just simply go and override the equals method, right? Override the equals method, right? Override the equals method. So just override the equals method, and here you can just compare the value of the name, right? Maybe let's say the laptop name, right here, laptop name, right, equals to obj laptop name. I mean this something like this, right? Laptop name. You can do this, and if you run this now, this will return me true, right? So for this case, this is fine. This will return me true. But when it comes to the case two, where you want to deal with the data structures which are provided by the collection, right, which uses hash data structures provided by collections, right? If you want to use them, specifically hash map, right? For hash map, right? For hash map, let's say you already have overridden the equals method, right? You overridden the equals method, right? If you have done this, right, it and you have overridden the equals method, and you see, and what we want is we wanted something like this, right? That this is the so L1, L2, L3, right? Like this. So we wanted to have like frequency here, 1, 1, 1. In case of L3, we do not wanted to add an entry, but we wanted to see like this, right? 2 here. But if you have done this, right, you will not be able to achieve this. It will still say L3 and add 1 here, right? It will do something like this. It will only do that L1 and L3 will only compare them as similar if both returns true. That is, your equals method also is okay, and you the hash code of both the objects are same. So obj1 hash code should be same as obj2. If that is the case, only then it will treat those two objects as same. If not, it will treat them as different. Let us go and work on our frequency counter again. So we had this, right. Let's go back here, fs programs. If you see this here, let us see the behavior. This is test laptop frequency. We added three things: laptop, apple, and we were adding it in the maps, right? Right, we were providing it here at frequency list object, which is here. It was getting the input list, and it was traversing it, and it was checking, right? So are we printing this? Yes, we are printing. And let me just check the laptop method once more. Have we override? Okay, we have overridden. Let me first show you without overriding again. See, the whole point of learning was that we were getting different outputs in case of frequency counters, right? For the objects. Let us try to become consistent there. So you can see I have three objects treated: Lenovo, Apple, and Apple, right? So these are like these things, right? A1, A2, A3. You can consider, right? And these are getting added. So now let me run this and see whether that works or not. So I'll just simply run this test case. So what is our output? You see Apple 1, Lenovo 1, and Apple 1, right? We wanted what? We wanted apple to be 2, right? Now let's do one thing. Now we learned about equals method, right? So let me implement that method. So if I go and implement this method, you can see, right? If now using this method, right, they are comparing the laptop name to laptop name, right? So we may think that since this contains key, right, is working on that current laptop only, right? The what we say, it is working on this, right, current the object part, right, the current laptop only, right? So we may be thinking that it should go and override the behavior, right? And what we should see is that apple is 2 and lenovo is 1. So let me just run it, but you will find that is not the case, because we have not still yet implemented the hash code method. What is hashing, I will come to that after this, okay? But let's see. If you see this still says apple 1 lenovo 1 apple 1, right? Now let's implement the hash code. So what I will say is, I will say public int hash code. So till now we have not achieved our intended objective, right? We have not achieved that. Now we'll achieve it. Int hash code, okay? And we are going to say return laptop name, okay? Return object dot hash, and we'll provide this value objects dot hash. Okay, let me import this objects dot hash and the, sorry, not this, laptop name. Okay, and if I do it now, let's see whether it works or not, or some other modifications also required. Let's run this. You see, this time you received apple as 2. Are you getting this, Sudhakar? What
A
is
small
happening is,
doubt. Like,
yeah,
we
yeah,
are overriding the hash code.
yes.
I mean, the hash code will be having two objects, right? Or like will be having everywhere. I mean, everywhere. Laptop is a variable.
See, okay, let me
Laptop.
explain this again. See, try to understand that whenever you create an object, right? Whenever you create any object, whether you create a string object or whether you create a custom object, right? So we created a laptop here, right? So again, this is the object class, and you have a laptop being created, right? This is an object created from the laptop, from the object class, right? And this is the laptop class which you have created. Now, from this laptop class, right, what you have done is you have created two objects, right? One is what, uh, L1, right, which is pointing to what, it says new laptop apple, right? This is one thing, okay? This is L2 new laptop. It says what, it says lenovo, okay? And then you have L3 equals to new laptop equals to apple, right? So here three objects. Now if you look at your laptop class, your laptop class looks like this. Oh, yeah. Your laptop class look like this, right? Your laptop class is this. Inside the laptop class, you had only string laptop name, right? You did this, and you took you called the constructor public laptop, right? And you took the name of the laptop name and did whatever we have to do, right? So laptop name equals laptop name. We did this. Now coming to the two method, right? Initially, you have not overridden equals and hash code, right? So they are not there. But try to understand in Java, right? Whenever you create an object, whenever you did this, right? So this is the heap memory. This is the heap memory. What will happen is an object is created here for L1, an object for L2 is this one, an object for L3 is this one, let's say, right? Every object, once created, right? It Every object has a hash code given to it. Okay, this will be generated by the Java. So let's say since you are not overriding it, so every object will have a unique hash code. Okay. So by default, then every object in Java receives a unique hash code. So let's say the hash code for this is HC1. This is HC2. This is HC3. Right. Now what I'm saying is in collections, right? In collections, and that too with hash maps, right? When you're working, right? You want to treat, right, L1 and L3 as same objects. Why? Because they have same values, right? But by default they will not be same, because these are two different objects and both of them have different hash codes, HC1, HC3, right? Now if you want these to be same, right, if you want these to be same, it is a compulsion on you that you have to override two methods. What are those two methods? One is this: you will have to override the method. Let's say you will have to override the equals method,
Equals.
where you
Equals.
will be
Yes.
first of all where you will be first of all updating the logic, right? Wherever you are updating the logic of, you are saying here, don't check the memory address, check the value within the object, right?
Value.
That is what we are saying.
Yes.
So we are saying
Yes.
compare laptop name, right? So this is one thing. So you're good with it, right? So we understand this part. So it will compare the laptop name. If the laptop names are same, then this method will always return true, right? So we did one part. The second part for the collections is that we have to also make sure that that object, right, for the object which you're creating, right, these two objects over here should return the same hash code value. If they are not same, right, if they are not like this HC1 and HC1, then for the collection, right, these are still two different objects if they are not same. So what we have the provision, what we can do is we can override the hash code method, right, and add the logic here, right? We can add the logic here, and we can say return, let's say, if you say one here, right, then every object of laptop will have 111, right? So right, which is not what we want, right? What we want is, we want that it should be based on some fact, right? So what we did was, there is a class here in Java which says objects dot hash, which finds the hash value of a string, right, or of anything which you provide here, right? So I provided laptop name. Now what will happen? Let's say for this Apple, right, laptop name is Apple. So let's say, looking at this value, right, which it had, Java generated a hash code of this, let's say 100, right? Now this is Lenovo. So again, the logic, so there is an algorithm for finding an hash code, right? And it is not that, I mean, it has to be consistent, right? If you provide the input Apple, right, at time t1, it returned 100, right? And if you provide Lenovo now, let's say it generated 101. Now, if you provide Apple again, right, what value it will return? 100 only, right?
100.
Because
100.
100 only. So what will happen here? Now these are having 100, this is having 101, and this is 100 again, right? Now what is happening? You have already override both the logics, right? This and this. And now since both
Yes.
are being overridden, now if you use this part, right, inside your what we say, in the class, right, you have overridden this, and you try to make that comparison within the hash map. Now this L1 and L3 would be treated as same objects. Okay, these would be treated as same objects. Okay, and why we are learning all this, because we wanted to know like how we can make two objects same in the perspective of a collection framework, right? So very important point, right, that how that there are two important methods, equals and hash code, and how they work. One last discussion on this, right? What is really a hashing, right? I'm sure like you are not maybe there could be a question like, why do we have this such kind of a hashing here, right? See, it is because whenever, right, see, collections is what? Collections is a data structure, right? Collections, we have different data structure, right? We have different data structures, right? Now the why we create data structures, the only point of create data structure is so that we can store the values, we can store the object, right? That is the whole point. Now if you are storing the objects, right, why are you storing the objects? Why we are storing the objects? So that at later time we can retrieve them, right? We can retrieve them, right, and consume them, right? This is the only point. So, and we can do some operations on it, right? Now try to understand, I when you're talking about maps, right, we know the how the structure looks like. We know that it has a key value pair kind of a thing, which is okay, right, which is okay. But this is something which we are seeing, right, which we see as an outsider. But internally, right, to manage the objects, right, which are placed in this data structure, right, it has to do one thing, right? See, collections only hold objects, right? We know that, right? Collections only hold objects, right? So even this complete row is like an object only, right? This is like an object only. This is also an object, right? Whatever you will do, this is like an object, right? Now even these are objects, these are objects, these are objects, right? So what happens here is, right, what internally the hash map, at least hash map, they do is, in this case, right, we wanted to have these two as same, right? L1 and L3 is same, right? See, okay, let's look at this. So you have this, right? So what they do is, what it does is, it creates multiple buckets within it. Okay, collection framework, right? What does it do with? It maintains different buckets. Okay, these, it maintains different buckets. Okay, now, uh, okay, so let's say we did not implemented these two, right? Let's say we did not implement these two, right? What it will do is, it will try to keep different types of objects in different buckets. So here all three are different, right? So it will place L1 here, L2 here, and L3 here, right? So it will do something like this. It will maintain in different buckets. Now let's say we wanted that, we have overridden this behavior, right, of that equals also and hash code also. Now what, how it will do it? It will again have these empty buckets, right, within collections. And what it will do is, it will check. It will see, while placing these in different buckets, right? It is checking two things, right? It is checking two things. See, okay, let me do it sequentially actually. So uh, let me go it here. Let me as a Java program. Let me grab this from here, and let's add this value here as a text box, and let's remove this and put it here like this. Okay. Now see what will happen. Now we are adding the entries, right? We are adding the entries over here, and these are getting added in the map, right? This is what we are doing. Now see, what is happening here is, by default, what Java will do is, the collection framework will do it. It will create three buckets, right? So it will say, okay, this is a new object coming in. Let's say this is A1, this is A3, right? Let's say. So it put A1 here, right? This was empty in the first time. So at time T1, it was all blank, right? It was all blank. So it put the bucket here, right? And buckets have empty buckets. At time T2, it looked at this, right? So this is being called at used at time T2. At time T2, it's so okay. New laptop Lenovo. So there was no object placed in any of the buckets, so it placed it here, right? Now, when it comes to at time t, right, it is checking for this object A2. Now, for the A2, right, it will check whether I already have a similar object with me already or not, right? But in this case, right, we have not overridden the hash code. We have not overridden the hash code and equals method. So both are not done. So what it will do is, for for Java, right, these are two different objects. So it will just simply add here at A2 in a separate bucket. Okay, like this. Now, right? And similarly for A3, right? It will do A3 like this. So this is at time T2, T3, T4, right? Let's say it will do in this way. Now let's say we said that, okay, we will make these equal, right? Hash code and equals as equal. Or let's start with the equals part. Okay, let's start with the equals part. See, even if you just make it equal, right? Even if you just make it equal, right? And not hash code are not equal. But what collection does is, it always looks for these two methods, right? So what it will do in this case, let's say you just implemented equal and not hash code. What it will do is, it will, let's start again. It went to A1. It say, okay, no, I could not see it as the same, right? Earlier case. So these are not. I mean, this is the first entry, right? So it created a new bucket and added a object to it. Now it went to A2, right? And A2 values are not same again, and hash code is not same, right? It will go and add in a different bucket like this, right? Now again, it will go and see A1 and A3, right? A1 and A3. It will check, does A1 and A3 have the same? Oh, sorry, it is here at A3 at this time, right? It is checking whether this object already exists or not, right? And here, right, while making a decision, it is checking the hash code value and the equals part. So the hash codes are not still same, right? These are not same. So it will go and add A3 here, right? Like this. Okay. Now again, the similar output. That's why you were seeing 111 as a frequency counter in this case, and similarly here also 111. Now what is happening is, when you started implementing the hash code, right, and now you said the hash code has been overridden, and these two have the same hash code. So let's say it has the hash code of h1, and this has h2, right? Try to understand that these buckets are created as per the hash code value, right? So this bucket will always hold the objects which have a same hash code value, right? So what will happen in this case? Now here in this case, what will happen is, again, it starts from this A1. It will say, okay, the hash code of this is H2. Okay, I will do what? I will add A1 here, because hash code is this, right? So it did this. Now it checked A2, right? So A2 hash code is different, right? So it did what? It just created a new bucket, assigned this hash code, and added A2 here, right? Now when it was reading A3, right, it checked, do I have what is the hash code of this? The hash code of this was H1. So it came to know, okay, so I already have a bucket here, right? So there is no need to create a new bucket. So it will not create a new bucket, and it will do what? It will just simply put this A3 over here, right? Okay, A3 here. Now what is happening here? We have two buckets, right? This one and this one. This bucket has a hash code value of H2. This bucket has a hash code value of H1. This bucket contains A1, and this bucket contains A1, A2, A2 and A3, right? But is A3 and A2 equal, right? This will only depend on the logic which you have written in the equals method. Okay,
Equals method. Yes.
okay. If you have not overridden this, this will still say these will still be considered as two different objects. Let me just confirm that. I think that is what I feel. Let me go and run this, and we'll do that, right? So what I'm going to do now is I'm going to comment this out. Okay, so let's say I'm commenting this out. Let's see it again, whether this will happen or not. So
This will not happen, I guess. I mean, we are overriding the value.
I mean, the hash codes are going to be same for Apple again, but the equals method, for equals method, it would be comparing the memory address,
Com,
right?
com,
Not the object, not the
yes.
value of the laptop name, right? So, but let's try. Let's try what it does. So I'll just simply run this. It should say Apple 1, level 1, right? You got it, right? So this is the part of hashing, right? And right. So and again, let me just reverse back my changes. So if I go to laptop again and I provide the here, right, like this. If I run this again, you will see it started treating these two objects as this, 2 and 1, right? Apple is 2 and Lenovo is 1, right? So now we know, now we have overridden the behavior of all those, and now we are very sure that we can do this, right? And now we also understood, like, if there is a need to have I mean two objects looked as, I mean, considered as same in Java, right? It is mandatory for us that we should make sure that the hash code value of those two objects are same, right? And we have overridden the equals method, right? And if we have not done it, we will see a lot of issues, right, when we are dealing with collections, right? And the power of hash code will can only be seen in the case of collections, and that to those data structures which use hashing. What are those? The names of the data structure starts with hash. Let's say hash map, hash set. Okay, so they all are dependent on the hashing value. Why set? Again, remember, right? Set keeps only unique values, right? Unique values. How does set identify these are unique? It identifies they are unique based on the H1 thing and the equals method again, right? You understanding this, right? This is similar to the keys in the map, right?
Yes.
Right? This is similar to
Got
the
it.
keys in the map, because what you need in the map is that your keys should be unique, which is a similar attribute like a set. So hash set also works in a similar way, right? It maintains different objects, these different buckets, right? And it checks whether, when it adds a new entry, it checks whether the hash code of those two objects are same or not. If they are same, they will be put in the same buckets. If they does not have a same value, a new bucket would be formed and the object would be added there, right? And within the bucket, if you want to compare whether these two objects are equal or not, you have to make sure that equal method is overridden, right? And this is how everything works. Okay, and this is what we wanted to learn. One last part about hashing. Hashing is not a simple concept, right? Hashing, right? If you see, right, I did not introduce. See, look at this, right? Look at this value. When I was writing this, you see this. There's a hashing value generated, right? It's a hash code generated, right? Who is generating this? Who is generating this value? This method here, which is the objects.hash. This was, it was generating that hash value, right? This over here was generating this, right? Now, if you look at this hash code, let's go there. If you look at this hash code, array hash code, right? Let's go there. Somewhere, someone would have provided the implementation of this, right? Let's say you can see, right? Again, I could not see an implementation here. Let's go here in the hash code also. Okay. Is it not clickable? Oh yeah, it's clickable, right? Okay, let me go to the implementation of it. Go to implementation. Searching for inheritors of object. Let's see whether it will be able to find or not. What I'm trying to say is writing a logic to find the hashing, right, is not a cup of tea. Okay, it's not easy as that. It requires, it has its own algorithm to find the value, right? So what is preferred is that we should not be trying to have our own hashing logic. Okay, we should never try to have our own hashing logic. So what are these? I think this is the one which we wanted. It could not find, right? I don't know like where it is, but the logic is not visible to us. But try to understand, right? Trying, I mean, an object having this hash code value, right? There must be an algorithm which is finding this value for that object. Okay, and it is a discussion for a PhD. Okay, it is a discussion for a PhD, like, or for higher I mean studies, right? that that people do PhDs and higher studies to work and come up with a logic to find an efficient hashing value. Okay, so what we'll do is, so what I'm trying to tell you here is, never try to uh, create a logic for hashing yourself, right? Try to use the existing methods which Java has provided you, right? And what are those methods? One of the method which I showed you is this objects.hash. Okay, you can just provide as many values as you want right here, right? Like you can see I'm providing a string value, this is an int value, and you can keep on adding those values, right, which you want to combine together, right, and decide the hashing value for it. Okay, if two objects have laptop and ID is same, right? Let's say, right, let's say apple 1 and apple 1 again and apple 3, right? So what will happen is the first two objects will have the same hash code value because of the logic, and the third will have a different hash code. Okay, so this is what I'm trying to say, the last part on finding hashing value, right? You can depend on this, but the last part, right, why we learned about all this? Because we thought that we can add in our maps, right? We can add in our maps keys as objects, right? As custom objects, right? As custom objects, right? We wanted to have my laptop object as the key, right? So Sagar, this is where the discussion started from, right?
Yes.
Right now, I'm now addressing this question itself, right? My preference, right, or my, I mean, what I would really suggest here, right? My suggestion is never use your custom class as keys. Never try to do that. Okay, we did that and we were able to achieve what we wanted to, right? But we should never do this. Okay, we should never do this. What are the, how, I mean, what can we create as keys, right? Let's understand. See, what we should always try is, if you are trying to create a keys for your map, right, always try to have it as a string, right, or as a wrapper class, any of the wrapper classes, right, which you feel can have a different values, right? Let's say integer, right? Integer is a good class, right, which you can have. Characters is another brilliant class which you can use for the keys, right? What are those? Boolean would not be a good choice. Float, again, it will have a decimal value, so not a good choice. But you can still have the other parts of the integer family like short, long, or byte, right? You can have these as the keys here, right? So these are the preferred choice if you wanted to have a key in your map, right? Never try to use your custom objects as the keys, right? Because why I'm saying this is because we understood, right, how keys works. It is heavily dependent on the hashing value, right? And these strings, integer, character, short, long, byte, right? The creator of of these classes, right, they have taken the pain and the necessary steps to generate, to make sure that the hashing logic, right, for these classes are working as proper as they can, right? So they have already have an inbuilt find, I mean, hash logic, right, to find the hashing value for all these items. If you try to create your custom class, right, and try to use it as a key, right, it is on you to have that hashing logic, right, to find the hash code. And you, because you are not an expert, I am not an expert, right, in finding a hash code, so we may get into a trouble, right, while doing this, right? So we should never do this. We should never use a custom class as keys. Always try to use these only, right? In our case, what we could have done, instead of adding the laptop entirely, right, I could have taken the laptop name from that laptop object and used it as a key, right? It would have what? It would have something like this: Apple as a string value, right? Lenovo as a string value, right? And third, when it checked for the string again, Apple, it would have seen Apple is already there and would have increased the value, right? It would have done like this. You're getting the point, right, Sudhakar?
Yeah, got it.
Right? Let's complete that discussion of ours, and we'll wrap up the class. So I'll go back to frequency counter, and instead of adding it as a here, right, like this, let me just copy paste a new. Let me create a new method. So we were able to achieve this using this hash coding logic, which is okay. And let's go back here and see this here. This time I will call what? Okay, let me use these. Uh, okay, not like this. So just see. Laptop frequency using using uh, using object string as key, right? Let's say this. And over here, what we're doing is we are passing it over here. Let me create a new method which will do that logic. Oh, I don't need to create a new method, or do I need to create it? It is having a string, like, okay. Let me do one thing. I'll copy this and create a new logic. And here, instead of working on the objects, so object string as key, let's say, right? As key. So I'll just copy this. I'll come back here and I'll call this method here, right? So we did this, and over here I am taking the input list, and now I will not use laptop. Okay, I'll not use laptop. I'll provide string. So this is the hash map, and we are getting the current laptop. So laptop equals to lap. Okay, this is not here. We'll do what? Uh, okay, no worries. Let me take laptop only. Laptop equals to this, which is okay. Current laptop equals to input dot list dot get I. And in the map, right, I'm not going to just check the object. I'm going to check the laptop name. Okay. So, and I will do here is I'll copy this and paste it here, and I'm checking the this part and this part. Okay. Let me do one more thing. Let me not use like this. I'll create the here laptop name equals to this value and string. Okay. So just a second. Sorry, Control S, Control C, and this value not here. It should be below this. And let me remove this. It will be null by default. And we have this laptop name, and I will just remove this one laptop name to make it more readable. And see this, right? And what we are doing is we are returning this, and this is a frequency map which we are generating. Why it is complaining? Okay, string, right? So this is all happy, and let's just collect. While we are calling this, we do not should not be collecting laptop. We need a string here, and what we need is it would be string as a key, and we're doing this right, and this. Now see this here. What I will do here is there is no need to even do any of this. Okay, there is no need to do any of this because the string class, right? When you will use string as a keys, right? They already have that logic of hashing and equals method there, right? So there is no need to append that logic. Okay, let us see. I think there is no need, but let's try to run it. Let's see. We expect the output should be what? Apple should be two and Apple and Lenovo should be one, right? So let's run this. Why it is not? I'm not getting an option to run it here. Okay, at the rate test is not mentioned. Rate test. So let's trigger this. Let's see what we get. You see, laptop 2 and Lenovo 1, right? To achieve this, to achieve the same thing in case of a custom class, right? There was a need to override both the methods, equals and hash code, right? But when you started using a string as a key, right, there is no need because string class already has an overridden logic of for both the methods, right? And while keys are being added as a string, right, the logics are taken from the string class and they are being decided based on them, right, Sudhakar? I hope this is all clear now,
Yes. Yes.
right? And now, but what is the key takeaway from all these last 3 days exercises here? The key takeaway is that whenever you are working on a hash map, right, on a hash map or on a hash set or anything which requires hash, right, which has a hash as a pre word over there. In all these cases, right, never try to add custom classes, right? Always try to deal keys as what? As strings or wrapper classes, right? Which are what? Integer, short, long, byte, or the character class, right? Because you can have different values in it. Even character has a limitation that you cannot have beyond 26 characters or beyond 52 or maybe hundreds of characters, right? After that, you may get stuck over there, but with the other things, right, you can have an infinite kind of a number sequencing, right? So the better choices would be the integer family wrapper classes over there. So again, the key takeaway is never use keys, never use custom classes as keys because there might be a chance that the logic which you first of all they might be a chance that we have not overridden the equals and hash code method inside this. And second chance is even if you have done the hash code with the logic of finding a hash code is not correct. Okay, so we should never try to do this. Our first choice should be string and the wrapper classes, which I just mentioned, which is specifically the integer classes, integer wrapper classes. Okay, and this is it, right? So I think this also marks our discussion end of the hash code and equals thing. And I hope with the understanding of this bucket sequence, it made more clarity. It brought more clarity, like how things works. Okay, and I think we are good for today, right? So any questions you may have, Sudhakar, or we are good to wrap up the call?
No, no, I'm good.
We're good, right? Okay. Okay, then. Thank you, Sudhakar. Okay. So
Thank
we'll
you.
meet in tomorrow in evening class, right? Okay. Thank you. Thank you. Yeah. Bye. Take
Okay.
care. Bye.
Bye.